go through, I brief you the course outline. The correct code kan, BEC 3023. Okay, this is a core. So this course, fuel and combustion, basically the synopsis is to cover the industrial combustion process. Okay, where the student will learn the fuel characterization, thermodynamic analysis, and how to quantify the performance and combustion process. Then you will be exposed to combustion appliances like furnace, boilers, okay, and how to derive the preliminary design calculation based on the process spec. And you will also be introduced to sustainable fuel and combustion development. Okay, and you will also be exposed to environmental impact of the combustion process and clean combustion technologies. So basically, in this course, you will learn fuel and combustion, starting from the fuel. So what type of fuel? Coal, solid, gas, liquid. So kalau then analyze the properties, the density, everything. Then how much the energy can be produced from that particular fuel. Okay, so from the fuel analysis, go into the combustion chamber. So inside the combustion chamber, you will learn on how to, what are the gases that will be produced from the fuel that you will use. So that's why, in the first place, the fuel too, it is important for you to characterize whether they are the sulfur, they are the chlorine or not. But that one will determine the gas produced at the end. Then you will learn to do a stoichiometric combustion equation, like metric balance. So component of fuel, let's say CHON. You buat metric balance, then apa yang akan keluar. That's why this course, the prerequisite, I put it here for thermodynamic, intro to material and energy balance. But for energy, you ambil ke material energy balance? Tak ada kan? Thermodynamic ambil kan? So because you will need to extract the info from the thermodynamic table. Material and energy balance, this one just a simple one lah. Okay, so basically these are the CLOs. First, you will need to describe the characteristic of various fuel. Like I mentioned just now, solid, liquid, gas. What are the density, boiling point, flash point? Okay, then the ClO2 solve the combustion system using combustion thermodynamic principles. Means what are the enthalpy involved, the energy produced, the calorific value, everything. Then ClO3 analyze the performance of combustion system according to material balance and thermodynamic analysis, the stoichiometric equation. ClO4 describe the various technologies for the production of sustainable fuels. Sustainable fuels here, we will cover from, let's say, for example, bioethanol from biomass. Sustainable. Kan dia biomass waste. For example, agricultural waste, convert to bioethanol. That one is sustainable fuels. Then ClO5 to analyze the environmental impact of the combustion system. So from the combustion system, you akan produce gases. So from there, you will need to analyze whether it impact the environment or not. Because like in Malaysia, we have the standard, the air pollution standard. So the CO2 release, dia exceed or below the standard. If exceed, then what you need to do? Okay, so these are the assessment. We'll have midterm, test, assignment, and final exam. Midterm will cover CLO 1 and 2, test 3 and 4, assignment will cover all. Okay, so basically the assignment I will release by around week 8, something like that. because it will cover from the first topic until the last topic. Okay, so these are the topics: fuel characterization, then thermodynamic and combustion process. This one will involve a lot of calculation. Then performance analysis of combustion system. Okay, combustion equipment. You will not design, you will only be introduced to the design. Then sustainable fuel and combustion technologies. Some introduction on the fuel cell as well. And also the last part would be the environmental analysis, the calculation of emission index, everything. Okay, so these are the textbook similar to your thermodynamic. Thermodynamic guna Chengel ke guna another one? Okay. Black book ke which one? Okay, this one because fuel and combustion, it is covered as one topic in this textbook. One topic. I don't remember which topic, but one topic. This one basically more towards mechanical student using this textbook. Because basically in mechanical, they also have combustion for their engine.
To thermo subject. So one from chemical thermo. Second one is
Mechanical part.
thermo 2.
Oh.
So basically for mechanical students, they have their thermo 1, but I did not join them. So I just straight away I joined their thermo 2.
Oh, thermo 2 cover which part?
Well, which part?
Still remember? Still remember. First law, second law lah.
So cycle the combustion with so the chemical combustion and reaction.
Oh, ada juga combustion. Then would be
Just with refrigeration cycle.
Then if you dah touch combustion, okay, sikit kot. Ada basic lah. Okay, so basically that is the course outcome lah. Course learning outcome. The rest is similar to other courses. Any question? No, okay, since our this semester banyak cuti hari Khamis. So today I will just start chapter 1 lah. Just a brief one. Dah ambil numerical ke belum? Numerical, dah ambil belum? When should be taking?
Sem tapi tak offer kan.
Dia May and September. Last time because clashing kan?
Student.
Sebab chemical yang course ni untuk old cohort, old intake. So yang current intake dah tak ada fuel as elective. Kita dah go towards other specialization.
Seorang.
Unless ada student yang fail chemical, dia repeat. Tapi so far I think tak ada. Untuk SEM ni you ambil course apa lagi?
Genetic conversion and voltage transmission. Tapi itu tak register ni sebab tu elektif. Dan saya pun tak subjek gitu dengan itu pun tak habis saja. So for example saya tak ambil lagi electrical power for year 1 lah sebenarnya. So saya tak sure saya boleh lompat terus ni.
Tak ambil sebab clash ke apa? Subjek tu?
Sebab memang dah tak di subjek lain yang offer.
Okay.
Bincang dengan Dr. Yap.
Win Dr. Yap ajar. Yang lagi satu tu?
Saya tak register lagi. Saya
tak tahu. Tak pastilah. Yang Dr. Yap tu kelas malam kan?
Semalam. Sebenarnya kalau kelas dengan Dr. Yap fleksibel lah. Sebab student pun 6 orang. So dia boleh lah. Macam kita orang solat ngaji last semester 2 orang student. So fleksibel lah. Kita boleh buat kelas ke Blok A. Sorry. Level 3 kan. Kadang buat kat situ, kadang buat kat lab. So fleksibel. Timing pun fleksibel. Saya kalau minggu ni saya tak available.
Okay, before we go to the lecture kan, saya pun nak discuss juga about that one. Okay. Okay, so basically fuel and combustion starting from here. Yeah, you need to focus kat sini, burning of fossil fuel, any types of fuel lah basically. So from there, then the gases will be released to the atmosphere. So from here, we can see the circle lah, how from the burning activity, how it will impact the atmosphere, then produce CO2, then CO2, how it will affect the ocean and the environment as well. So the CO2, apart from being stored, okay, the excess will be stored, and then it will also be used untuk respiration by the from the produced from the respiration. So CO2 will be used by the plant for the photosynthesis as well, right? Okay, so here this is the circle of the combustion. Basically, the general concept lah. Fuel, the coal, oil, gas, or what? Then where this come from? Fossil fuel. Okay. Then burn, then it release the gases. Where the gases go? Either used by the plant or stored. Current trend now, they are looking for the CO2 storage, right? Okay, we go to fuel characterization, where you will learn the fuel classification, proximate and ultimate analysis, and also the calorific value. Okay, the fuel characterization would be to identify the chemical contents of the fuel. Let's say kalau you ada, let's say you use petrol, kan? So you ada CH. So from the CH, here ada dia punya amount lah, how many of C and how many of H. Then react with oxygen, combustion kan. So here you will produce in general CO2 plus CO plus H2O in general, right? And then the important to identify the chemical contents because you need to know what will be produced. Because from here it will impact the environment. Okay, then to identify calorific content of the fuel. From here, from the element, you akan tahu how much energy that can be produced. Macam kalau you tengok dekat thermodynamic tables tu kan, dia ada kalori, berapa banyak energy dia akan produce kan. So that's the objective to do the fuel analysis. And then to evaluate the potential of fuel for energy generation. Okay. Then to determine whether the given fuel is suitable to be used in the current combustion system. Current combustion system here means sistem yang ada at that power plant ataupun dekat kilang. So kalau dekat kilang tu dia guna solid fuel. So fuel yang you ada tu sesuai tak untuk combustion system tu? Kalau let's say power plant tu guna macam gas. So nak kena relate whether suitable or not to be used. Okay, so to classify the fuel by physical, chemical, and also by its sources. Physical characteristic here means macam dia punya flash point, and then flame point. Okay, chemical contents tu macam composition dia lah CHO, Okay, so physical characteristic, this one is the general one. Solid, We have liquid, also the gas. Solid, for example, coal. Okay, gas, perhaps like butane gas. Liquid, maybe diesel, for example. Okay, for gaseous fuel, usually the natural gas, the LPG, coal gas, coke oven gas, producer gas, and biogas. So in gas phase lah. The characterization that is important to know is the volumetric analysis, the density, and the heating value. Usually, the heating value is usually the industry will focus more lah, because from the heating value, you need to know how much energy produced and how much energy will need to be used. Because energy equals to cost. Cost and yes, correct. Then liquid fuel, primarily from crude oil. The sources from the crude oils, it can be all these liquid butane, liquid perhaps diesel, petrol, gasoline. Okay, and the molecular structure, it can be this type of structure. Dia ada ambil organic chemistry tak? Tak ada. Let me know kalau terms yang you tak faham sebab saya dah biasa dengan budak chemical. Okay, properties of liquid fuel. Liquid fuel, for example, just now, diesel, gasoline. So kita akan tengok what is the density, the viscosity, flash point. Viscosity tahu? Yes, kadar kelikatan. Flash point, bila that fuel start to burn dengan sendiri. Bila kita bagi heat, kita tak bagi source of ignition pun. Kita just heatkan dia and then at some point dia akan sendiri terbakar.
The point is temperature.
Yes, temperature. Bila dia sendiri terbakar. Kenapa penting? Sebab kita nak tahu at what temperature dia boleh terbakar sendiri. So that temperature, if high temperature, it will cause high energy. Okay, then 4 point, specific heat, then calorific value, the energy that will be produced lah. And also the sulfur content. Because ini nanti kalau dalam fuel tu ada sulfur, you akan produce sulfur oxide, which is harmful to the environment. Or you will produce hydrogen sulfide. Itu lagi danger. H2S. Then the ash content, kena tahu juga sebab bila kalau let's say you bakar coal yang high ash content tu dia useless. So dia akan termendak kat bawah furnace. Macam kan, ash tu, minerals. So kalau banyak ash dalam fuel tu, nanti bila habis pembakaran, dia akan terkumpul kat bawah. So dia akan affect the combustion process. Kalau kita bakar sampah kan ada habuk-habuk yang tak terbakar tu. To ash. Then also the carbon residue and also the water content. Okay, water content penting sebab macam kita bakar daun yang kering dengan daun yang lembap. Kan? Kering tu yang akan cepat terbakar. So lembap lambat sikit sebab dia ada air. So yang lembap ni dia akan perlukan masa yang lama untuk terbakar. Then more energy. Let me know kalau I go too fast.
Okay.
Okay, then for the characterization of liquid fuels, okay, basically the heating value, the specific gravity, the viscosity just now, flash point, auto ignite, then also the distillation curve. And all these things lah. Octane number, cetane number, like macam gasoline, petrol kereta tu kan ada RON 95. That also will be taken into consideration lah on the combustion process. Cetane number more towards diesel. Ada alkane. Dia nak tahu alkane, tengok ni A and E ni. N. Okay. Okay, so ini contoh spec of fuel oil. Usually from the supplier, kalau beli fuel oil, these are the spec that they will share with you. Okay, then solid fuel. Basically, the source of solid fuel would be the wood, plant biomass, like agriculture waste, okay, rumput ke, and then the palm oil, empty fruit bunch, then the peat, municipal waste, animal waste, coal. Okay, coal, it has 3 categories: bituminous, anthracite, and lignite. Bituminous, I think bituminous is the best coal to be used for the fuel, for the combustion process. It depends to the quality of the coal. Yang buat kat jalan tu kan? Yang tu, that one different. Different. Cool. Yang tu bukan coal. Yang tu sebab kalau coal yang tu, nanti saya share mana tadi. Sekejap. Okay, dia. Yang coal. Dia ada anthracite, bituminous, and lignite. Dia focus on the fixed carbon content. Anthracite yang the best. Dia ada high fixed carbon. Because high fixed carbon will produce higher heat content. Bituminous dengan bitumin jalan tu lain. Different thing. Okay, back to this. This the agricultural waste. Sekarang ni, they are moving forward for palm oil industry yang empty fruit bunch to be used as the one type of fuel. There is one company in Perak. They are using that for their combustion process to generate their energy to their own plant. Okay, these are the solid fuel contents that you will need to analyze: hydrogen, oxygen, nitrogen, sulfur, ash, water, and carbon. So basically, later on you will see the chemical formula of the fuel: CHONS. Okay, so these are the important ones. Okay. Okay, untuk solid fuel analysis, this one only for solid. Kita ada proximate analysis and ultimate analysis, and then identify the heating value, and also some consider the coal grindability. This one if it use coal. Okay, coal only lah. So the rest, like say like biomass, doesn't work lah. And okay, proximate analysis. Proximate analysis, these are the components that we will analyze. How much is the moisture? How much is the ash? Volatile matter, fixed carbon. Volatile matter tahu? Volatile matter tu macam bila kita burn, dia senang dia senang vaporize. Dia senang terbakar. Kenapa dia penting? Sebab so bila dia senang terbakar, so dia akan cepat release to environment. Fixed carbon ni basically from here we will know what is the calorie value, the energy that will be produced. Ash tu macam tadi lah, dia termendak kat bawah tu. Okay, proximate analysis, these four. For ultimate, kita akan go for elemental. Elemental, kita akan cari how much of the carbon, berapa banyak hydrogen dalam the fuel, sulfur, nitrogen and oxygen. So basically yang ni either buat dekat lab untuk identify ataupun kita boleh buat send to lab to analyze lah. Ada specific equipment. So from there, let's say kita dapat berapa content percentage all this kan. From there nanti kita kena generate the combustion equation to predict gas apa yang akan keluar nanti. Okay, so this for example, farm waste. These are the proximate analysis. Ini tak ada moisture, might be dry basis. But sometimes supplier akan bagi as dry basis or wet basis. Kalau dry basis, dia tak adalah moisture content. Kalau dibagi as in wet basis, then dia akan ada moisture content. Then ultimate analysis, so these are the component yang ada dalam farm waste ni. So from here, you boleh predict gases nanti akan ada sulfur and chlorine.
Will add up in 200 or it's actually separate?
Okay, yang ni total dia akan jadi 100. Yang ini not necessary. Because yang ini it based on the elements only. Biasanya ini plus ash, then only become 100. Okay, so this one is tire waste. Proximate, okay, this one wet basis, dia ada moisture. Ultimate analysis, so dia ada semua ni lah. Dia tak ada CL kat sini. Then they provide as well the higher heating value, the energy and also the molecular weight. Okay, dekat sini dia dah bagi chemical formula of the fuel. Sebab apa penting untuk generate? Untuk nak predict gases nanti. predict gas one thing, and also predict how much air yang you nak guna untuk the combustion process. Kan combustion plus oxygen kan. Dalam course ni kita go details which include N. Air is N and O kan. So kita akan calculate how much air as overall. That's why in industry, kalau basically dia akan main dengan air fuel ratio. Itu yang penting. Berapa banyak air yang perlu untuk supply, let's say 1 kilo per second, 1 kilo per hour fuel. So berapa banyak air yang perlu. Kalau air tak cukup, pembakaran tak lengkap. Bila pembakaran tak lengkap, nanti combustion chamber tu dia akan jadi macam hitam kan. And then energy tak banyak lah. Kalau air lebih sangat, nanti compressor design tu over design. So kat situ pun cost. I pernah pergi Top Glove dekat Kelang kan. Kelang. They have issue on their boiler combustion chamber. So kita buat collaboration research lah. Dia tengok dia dealing with air fuel ratio issue lah. So that's what I suggest to them to see the air and fuel ratio. Because basically kalau combustion ni, kalau dia tak okay, dia main dengan air fuel ratio tu je. Kalau pembakaran tak lengkap, you akan ada banyak gases produce. Kalau pembakaran lengkap, you akan fully CO2, H2O. Okay, proximate analysis. Macam mana nak tahu moisture content, fixed carbon, voltmeter and ash. Apart from hantar pergi lab, ada equipment. Itu yang the best lah, ada equipment. But kita boleh cari juga dekat lab sendiri. Moisture content, we do moisture content analysis where let's say kita guna sample coal lah. Okay. Kita wait before drying, then send to dry, then wait after drying. So from there kita tahu how much is the moisture. Say before dry means the raw, then go for drying, then after dry. So weight dekat sini M1, let's say M2. Kita nak tahu dia punya moisture content, M2 minus M1 over M2 multiply 100. 100%. Then you will know what is the percentage of the moisture content. Then this moisture content analysis at this temperature only. Sebab air kan, H2O, vaporize at this particular temperature. Then the fixed carbon, we will use furnace at this particular temperature to know the leftovers solid. Itu fixed carbon. Volatile matter, here mention covered because bila masuk furnace, dia dah terbakar, volatile matter dia akan senang terwap kan. So that's why kita cover so that we know how much of the volatile matter being released. Then the remaining residue is the ash. Ash basically contains of minerals like magnesium, calcium lah, that one the general one.
Ia berlaku dalam satu tempat dibuatkan
Dia banyak step.
pemilahan
Contohnya kita ada macam moisture content ni, dia tak payah masuk furnace sebab dia 100 je kan. So dia masuk oven pun dah boleh. Masuk oven. Kalau yang ni, yang high temperature, kena masuk furnace. So yes, kita guna satu furnace je, tapi a few samples lah. Maksudnya satu untuk nak check fixed carbon. Satu untuk nak tengok what is the volatile matter. Satu lagi, from there kita tengok apa ash residue dia.
Still, tapi dia punya suhu tu, ni kan, suhu dia tetap.
Basically around this range lah. Sebab carbon, sebab sini kita nak check carbon kan. Carbon basically sama je. Around this range lah. Volatile matter, it depends pada raw material tu lah. Okay. Okay, ultimate analysis. Ada two methods. The chemical means here the lab method and also the spectroscopy using the equipment, the machine. This one, if you were to analyze in the lab, okay, these are the method. I will not ask the details on how to do it lah. Just to introduce you how it can be done. Okay, this one using the equipment in the lab, we just pass them the sample, then they will put in the sample into the machine, then analyze for you, come out the results. So basically, these are the standard that we always follow. ASTM, the American Society for Testing and Materials. Why we follow? Because this has been published. So we just, let's, at least we have the standard. Then also we follow European standard. This one for biomass fuel. This one untuk nak analyze the fuel only. Kalau gas release nanti, kita biasa follow DOE standard. Department of Environment. Yang Jabatan Alam Sekitar. Okay, ni yang coal tadi. The classification of the coal. Main one is 3 lah. But here, the bituminous split into sub-bituminous. Anthracite, bituminous, sub-bituminous, and lignite. Anthracite, as you can see over here, the content of the carbon. Okay, they differ by the content of the carbon. Okay. Okay, ini dah share tadi. The content of the carbon for each type of coal. So anthracite has the highest fixed carbon. Okay, usually we will focus on the fixed carbon because from there it relates with the heat produced. So that's all for chapter 1 as for introduction. Boleh faham tak?
Sikit sebab saya kan baru habis intern kan. Intern memang fully solar lah.
Oh, solar.
So memang ada solar nak masuk combustion pula memang dia take time lah sikit.
Dia nak relate tu memang tak relate sangat lah.
Solar ini take time lah sikit.
Solar, dia guna solar panel tu kan? Solar panel tu buat dari apa? Silikon. Solar tu dia absorb heat ke? Absorb heat ke absorb light?
electricity, ni, light.
Oh, kalau electricity light.
Dia pending untuk panaskan air,
Mm-hmm.
untuk shower. So, tu dia absorpsi.
Jadi sekarang kan ada sekarang yang panel yang fleksibel tu. Dah commercialize ke benda tu?
Dia tu belum commercialize. Masih R&D dia.
Oh. So